Here's a demonstration of how you can start from a user form and then determine the normalized database structure based on that. So user forms are useful for asking the users for data that will ultimately be stored into a database. And so a lot of times the user forms are one of the documents that you will use for analyzing and designing the database. So it's good to know how the normalization techniques uh, apply to the attributes that are shown on the user forms. And here's an example of a user form. So this form is from Murray State, and this is a form for on-campus housing exemption application. And so it's asking for which semester you are requesting, and name of the student, M number of the student, what student classification is, home address, local address, and so then there are these areas where the user will type in or handwrite the data. And then there are sometimes you have a form that's got multiple instances of another piece of information. So here we have, this is a student requesting housing exemption. Then the student needs to list all the reasons why they may be granted this exemption. And so multiple reasons, there may be multiple check boxes. And then this date, then there is a date on which the student submits that form. So all this information has to be somehow stored in some sort of a structured table. So that structured table must have structure such that there is no redundancy in the data, and that's why coming up with a good normalized database is important. And so with that kind of a form, you want to identify attributes. When I talk about attributes, a lot of times there are explicit attributes that are already shown on the form and which are easy to identify most of the time. And say for example in this case, attributes such as like semester, or last name, first name, classification of the student, and so on. So these are all attributes that can be, they're already explicitly stated. And then there are maybe attributes that are not explicitly stated. So we need to know about those too. So the attributes that are not explicitly stated, I'm going to call them implicit attributes. So a lot of times forms like this do not show the key attributes. So you need to uh, be cognizant of the fact that there may be tables that will be designed. Those tables will need key attributes because every table, every row must be unique, and a key attribute will ensure that. And also there may be multi-valued attributes in many forms. These multi-valued attributes may be shown as a form inside a form, maybe multiple repeated list of items. And so they call multi-valued attributes, and they may not be numbered as they are, like a line item or serial number, sequence number, and so on. So those numbers may have to be you know uh, added to your list of attributes because they're not explicitly stated. And sometimes we may have attribute values, they may be shown like attributes. So we need to be aware of that too. Then the steps in figuring out the normalized relationship, normalized relations, is to start with the attributes, and then among those attributes mark which may be key attributes and which will be non-key attributes. One basic rule of thumb: key attributes will be something that is unique, like a ID number, sequence number, and so on, or maybe a unique name or code, or those may be key attributes, and everything else will be non-key attributes. In addition, you got to be aware that forms will have title, header section, body, and footer sections, and there may be data buried in the title. Sometimes attributes may be buried in the headers, Well, most of the time there will be some attributes in the header section. Then there'll be a bunch of attributes in repeated multiple times in the body section, and the footer section may have additional attributes. So you got to be aware of that. And so those set of attributes in the body may be repeated, and they may not have explicit numbers. So that's what I was talking about, the numbering of multivariate attributes. And and also when you're looking at attributes on a form, a lot of times these attributes of a particular entity are kind of shown together. So these are some heuristics to kind of keep in mind while understanding and analyzing the form to create a normalized table. So here's part of the form, and so these are data input sections, and this is where people will be typing in or entering data. And then there's some more input sections, and also there is a date at the bottom of the form. I showed that also. So these are like boxes where the people check or not check, and so all that, check of a form of a box means something, an unchecked box also means something, so we need to be aware of that. And then of course the header section also has the semester, so there'll be also attributes. So once we got these attributes, we need to identify them. So I have simply shown them in red, like rectangle. And then among these attributes, I have name of the student. Name is made up of last name, first name, and middle initial. Now we could keep name as it is, and then later when we actually design the database, actually create last name, first name, and middle initial as separate, three separate columns. For now I'm just going to keep name only, then m number will be an attribute. Now there is classification, then there's a whole bunch of values followed this classification. So when you talk about an attribute may have the form may show attribute value. So this is an example of attribute values. So this is a attribute value of freshman, attribute value of sophomore, attribute value junior, and so on. So these don't become column names. So these don't become attributes. So you got to be careful, because the user will check one of them, and so that value for classification will then become sophomore if the student is a sophomore, or if the student is an ESL student, the student will, she will check ESL, so that becomes a classification. Same with gender. So gender is attribute, and male and female, these are values. So these one of these two values will be checked, and so we would um, those values will not become attributes, but gender becomes an attribute. Now, similar to name, when we are not worried about last name, first name, even with address, address is composite. It's made up of street, city, state, and zip. And so instead of treating these ones separately, I'm just going to, for now, look at only just home address as one unit piece of information. And phone number is also an attribute. Local address will be an attribute. Cell phone number attribute. Parent's name, and again it's talking about last name, first name. Perhaps while designing the final table, we can have separate columns for last name and first name. For now analysis purposes, we'll just treat it as parent name. Okay, then you have parent student email. All right. So now one other thing is this at reasons for exemption. And so I marked reason as an attribute. Okay, I didn't mark each one of these attributes values as attributes, because this could be this could be true or not true. Like for example, the first reason could be true or not true. So the student may check or not check this box. So that actually becomes a value. The what goes inside these boxes becomes a value. Now the values are also listed here. So value for reason is here, and value for the actual reason is here, and this is the value for the reason. So reason will be these list of values. Okay, and so I'm keeping reason as an attribute, and but not these individual items. Then I have marked date as an attribute too. All right, so now we will also track the value of each reason, whether it's checked or not checked, as as a as to be stored in the database, and will be a actual entry. All right, then implicit attributes, and this particular form does not have a serial number, so I will add a serial number as an implicit attribute. And also the reasons in here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 reasons. So, numbering of those attribute multiple multi-valued reasons will also need to be recorded, because we need to know which reason number the student has checked and so on. So numbering of multi-valued attributes will be another implicit attribute. Okay. All right. And based on this example, we have serial number, and the student information is part of the header part, and reason part is the body part. So that's the header and body, and individual reasons as attribute values of attribute reason. Okay, so we'll call reason as an attribute, and that check true false will be the actual value of an for reason. All right. So we'll also add a reason number, since there are no series and numbers to track. So this is a list of all the attributes. Okay, form number, semester, and form number is like a serial number, form serial number. Semester, student last name, student first name, student middle initial, M number, classification, and then we have parent name, student email, reason number, reason present. So reason value, I'm calling it reason present. So this value, reason present, could be the true or false. Then form date. Now among these, we need to first figure out what will be the key attributes. So the key attributes are the ones that are usually have a number in it. So it's form number, student M number, they and also we have a um, reason number. So these three fields, these three attributes, I'm going to call them key attributes, and everything else I'm throw them into this non-key attributes list. So we'll start with the original relation of these three key attributes on the left hand side, and everything else on the right hand side. Then what we do, we start decomposing this and creating smaller relations after analyzing the partial dependencies and transitive dependencies and so on. So find partial dependencies, and we know it has a lot of information about student. So let's attack that. So student M number will be the key, and given a M number, we can determine student last name, we can determine student first name, student middle initial, classification, gender, home address, home phone, local address, cell phone, parent name, and student email. So all these can be determined given M number. So there is a direct dependency between M number and these red lettered attributes. So there is a partial dependency. So we don't need to know form number or reason number to find student last name, first name, or student middle initial, and so on. We only need to know M number to find what the last name, first name is. So we kind of go ahead and remove them from the original list of uh, non-key attributes, and we decompose the original relation into one relation. One other relation called M number determines student last name, first name, and so on, all the other attributes. That's decomposition number one. Next decomposition is reason number. Okay, so the reason, I'm going to assume that the reason, each of the listed reason will be assigned a number. So that's what reason number is, and given a reason number, I can figure out what the reason is. So there is a dependency of reason to reason number, so that's a partial dependency. We can go ahead and decompose that. That's what I did. So the reason part is struck out, and they keep, of course, the left hand side of the relation must be shown as it is. And the next decomposition, form number. Given a form number, I can figure out what the semester is and what the form date is. So semester, each form is filled out for each semester, and so there's only one value for a semester. So given a form number, we would know what semester the exemption is for, and given a form number, we know when it was signed. So there's form date. So these two are these two attributes depend only on form number, not on M number or reason number. So there's a partial dependency. We decompose that. All right. So after removing partial dependencies, we end up with this form number, semester, and form date. This is student M number to student attributes, reason number to reason. This is the original uh, relation we had, and form number, M number, reason number on the determines reason present. Okay. So now we're still not done. We need to look at this original relation and see if there is any dependency among these key attributes. So we want to check for dependence among the key attributes and a form number, M number, and reason number. So each form is for one student. So given a form number, we can find out what the M number is. So there is a dependency of form number and M number. Okay. So this dependency can be represented as a relation like this: form number determines M number. So once we figure this out, we can go ahead and strike out M number from here, and what we end up with is form number and reason number tells you whether the reason present or not, true or false. Okay, so this part, there is no partial dependency. For reason present value, we need to know both the form number and the reason number. Only then we can tell whether it's true or false. So there is no further decomposition possible. All right, after removing the dependencies, this is after removing the dependencies among the key, we end up with form number, reason number gets you reason present, form number gets you semester form date. This is the original one. Then this is a student relation. Then this is a reason relation. Then finally form number to M number relation. So this form number, this number five, relation number five and relation number two both have the same key. So we can merge them. And after merging them, we get M number as another attribute. Since M number is a primary key in another relation, in this case, this M number is a foreign key. So this is the final relation. Okay, so this final relation has M number as a foreign key, and reason, of course, reason number is part of this primary key as well as it's part of this key also. So this reason number here can be considered as a, since it's not the entire key, it's part of the primary key. This can be considered a foreign key, referencing this particular relation. So in other words, for that particular form, we're going to end up having four tables, and these four tables will have this sort of relationship. All right, I hope you found it useful, and this will be useful for your homework assignment. Thank you.